to construct a confidence interval for a single unknown population where the population standard deviation is unknown. We're still going to use the same mu, and we're going to use the same margin of error. What changes is if we do not know the population standard deviation, we have to use, instead of the Z chart, we use the T chart. So T chart is in your notes. It is going to be given to you as a laminated paper, just like the Z chart. So you'll have both of them for the quiz and test. Okay? So when you are not given the population standard deviation, that is when you use the T table, T chart. Okay? And the reason why is because we have to do just a little bit of one more extra step, and then we use the table. However, the table is a lot easier to use than the other one is. So T star represents the critical value from the T distribution for the confidence level desired with using what we call the degrees of freedom. Degrees of freedom is n minus 1. What is n? The sample size. So you take, if the sample size is 15, degrees of freedom is 14. And then when you go look at your T chart, you go to the degrees of freedom is 14, then you go to the confidence level, and then it's going to tell you what it is. Now, when you look at the T chart, you're going to notice it does not have every single one on there, which means I will only ask the ones on that chart. Okay, it has 60, 80, 90, 95, 98, 99, 99.8, and 99.9. I can't ask you anything other than those. All right? Another thing to note, which you'll see in one of the examples, is it goes up by 1 until you hit 40, and then it goes up by 10s. So when that's the case, if you had like 62 as your degrees of freedom, you're going to round down to 60 and use the one that's closest to it, okay? Now, that doesn't happen frequently because usually the reason you're using this is you don't have a very big sample size. But do note that when that happens, that's what you're going to do on that. Okay, so the degrees of freedom is the number of sample observations that can vary after certain restrictions have been imposed. And if you take stats in the future, know that they'll use T sub alpha divided by 2. We use T star. It's the same thing. It's just notated differently. So if you ever take a stats class in the future, they may have different notations, but the way that you do it in the math is the same. All right, so when your T distribution, if you look at the top one, that would be if I have infinite degrees of freedom, that's going to be where it's your standard normal. So that means that you have a massive amount. That would be the perfect scenario. If you notice, though, what happens is the smaller your degrees of freedom or your n value becomes, the more flat it becomes. So what happens is it spreads it out. Instead of it being narrow, it kind of spreads it out, okay? So there are an infinite number of T distributions, one for each possible value for degrees of freedom. The T distribution has the symmetric bell shape. Same as the Z distribution, but it reflects the greater variability that is expected when you're estimating your sigma value. T distribution, just like the Z distribution, has a mean of 0. Big difference comes that the standard deviation varies with the sample size, but it will always be greater than 1, which is unlike the Z distribution. Z table, your standard deviation is 1. T table, it's going to vary. As the sample size gets larger, the T distribution gets closer to the Z distribution. So again, as you have a bigger sample size, it becomes more and more like your normal curve. So find the T star, the critical value, for the following. I have a 95% confidence and I have a sample size of 15. So if n is 15, my degrees of freedom is 14. And then now go look over on your T table. The left side is your degrees of freedom. The top is what your percentage is, your confidence level. So you're going to pair up 14 on the left with your 95% column.
2.145.
2.145.
Oh, I think I.
Okay. So really the big difference between last class and today is this value. Everything else is the exact same, but this value and how you find it is different. All right. Go find B and C.
You, Tyler.
Okay, so everyone needs to have their calculator out. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects, so N is 15. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population, which you can assume is normal, from which you took the data. So, from the data, the two things that we need is we need our mu and we need our sigma. So that's what you're going to use the calculator for. So go plug it into L1, and actually remember, for the calculator, mu is x bar, and your sigma s in the calculator, I believe it is sx is what they call it. All right, so now that you have that, now we go back to last class and we do the exact, so degrees of freedom is 14. I'm going to use T star. Go look at degrees of freedom is 14, and your confidence level is 95%. $2.145, right. So now we're going to do 8.2267 plus or minus 2.145. Remember to find error for population means it's sigma over square root of n. So times 1.6722 divided by square root of 15. Now make sure you use n on that, not the degrees of freedom.
Oh, yeah.
Okay?
Wait, so why would we not use?
7.
That's like actually really. What?
64 days.
Oh, you're at this call? Yeah.
Same thing.
Are we
Yeah.
not doing the calculator thing? Okay, cool.
All right. Example 3. Same thing, different numbers. So go put them in L1. Find your information and find your confidence interval.
Gee, I think I could be onto something.
I need to see what I have. Everything's great except my homework grades.
If you're passing the class
Are you dying?
Hilarious.
Miss G, I think I've got it.
I got the answer. Well, I got a answer. I don't know the answer.
I have an answer.
I have one, but I have no way to
I have the answer. You have the answer? It looks the same as my answer, so that's good.
Oh, you should have.
How did all have the same answer? That's so funny. Kylie must have cheated. There's no way we got the same.
All right, so this is really just kind of going over what we already did. So x bar plus or minus t star times s over square root of n. So that's the formula we just used, okay? It gives you your confidence interval, which is lower bound to upper bound. So the way that we interpret this, because I'm going to say find the confidence interval, and then I'm going to say interpret the confidence interval. The way we interpret it is we are this percent confident. So if it said 95% confidence level, we are 95% confident that the population or true mean, I don't care if you say true mean or population mean, either one's fine, for whatever it is that it was describing is between this number and this number. Okay, that's literally all, you're using that to write it. Then if I say check your conditions, remember you're checking, is it a representative sample, is it random? I'm going to tell you right now, it's going to be random. I'm not going to give you one that's not. So you can pretty much assume that the randomality is always going to be there, even if it doesn't state that it's random, okay? But you also do have to check that it is either following a normal distribution or the sample size is greater than or equal to 30. If it's not one of those, you can still find the math, but you cannot say that your results are going to be, they may not be reliable. So and you'll see that whenever we do a couple of these examples.
Is that the same formula?
Okay, a physician wants to test a medicine to lower blood glucose concentrations in diabetic patients. The drug is considered successful if it can lower blood glucose below 110 milligrams per deciliter. He uses the drug on 30 patients, and at the end of the trial, the sample mean is 102 milligrams per deciliter with a sample standard deviation of 3.2. Assumed values are normally distributed. So we're going to construct a 90% confidence interval for the true value. First of all, check the conditions. So it's random. Does it meet my other qualifications? Actually meets both of them. It is both bigger than 30 and it follows a normal distribution. So we know we're good. So you can either say normally distributed or n greater than or equal to 30 because both of them are met. It only needs to meet one. Okay, so what is my critical value? So my degrees of freedom are 29. So therefore, T star is 29 degrees of freedom, 90% confidence level, 1.699. Okay? Okay, what is the point estimate?
Say that again?
What's the point estimate? It's basically asking, do you know your vocab?
Is it that?
It's the mean. That's all it is. Your point estimate is the same thing as X bar, which is 102.
Margin of error.
Margin of error. So margin of error is going to be, no, so that's the part that you're in plus or minus this. Thank you. So this is going to be,
Your T star
error is T star
times NO
times 3.2 over square root of 30. Good. So my margin of error is 0.9926.
This is just testing you.
This is just seeing, do you know your vocab? Do you know what each piece is called? I may or may not. I may ask it in pieces. I may just say, give me the confidence interval, and you can just do it all at once. But you have to know it however I ask it.
All right.
Now, when you're finding the confidence interval, you're doing 102 plus or minus 0.9926, because you're doing plus or minus that 1.699 times, right?
Yes.
So my confidence interval is 101.0074 to 102.9926.
Is there a reason we didn't write out the fraction for the super question?
Because I actually found it right here.
Okay, that's how I was just
It doesn't matter if you want to rewrite it, that's fine, but yeah, it does not have any effect on it.
Good question.
All right, interpreting the interval. We are what percent confident? 90% confident that the true mean, or you can say the population mean, I don't care which one, of what were we checking? What was it testing?
The lowering blood sugar.
The blood glucose concentrations of the blood glucose concentration is between 101.0074 and 102.9926. So that is the wording you use to interpret your confidence interval.
Could I say between,
Why is the claim reasonable then? If you say that it is, why? So read the problem. What did it say it's considered successful? Lower than 110. Is our confidence interval the entire thing below 110? Yes, therefore we say that this is successful. So yes, because our confidence interval is below 110. Okay, I want you to go do A, B, and C, and then we'll talk about D together.
Yeah, that's what I say.
And we're waiting for you for the last part, Dean.
Mm-hmm.
I usually don't want to write poetry as Did you go to
Put your
Costco?
pants back.
I know, I was like, we're all gonna fail after her.
All the leaders were out, so second team
Job.
gave me practice squad.
Yeah.
All, everyone else.
Yeah.
I got an 80, baby. What you gonna get in English?
Austin, ChatGPT won't help you find your dad.
I was asking where did it go?
Why did we wait until the video was on for that?
I really hope you post these videos on YouTube. Use them next year.
All right. Address the claim that the mean weight of all hockey players is over 195 pounds. Agree or disagree?
Disagree.
Disagree because why?
The data tells us otherwise.
Okay.
Because the lower confidence interval is below that.
No, because the lower bound of the confidence interval is less than 195. Good justification.
Do you have to put the percent confidence level or anything in it?
No. All right, address all assumptions and the validity. Okay, it's random. Does it say in the problem it is normal? No, it says it is somewhat symmetric, but that does not actually mean that it's normal. And my N is less than 30. Therefore, it is random. It does not meet the second requirement. And what that means is our results may not be valid. Oops.
Is there a way to make them valid?